Hello and welcome to another section in further mathematics. Today we'll be talking about the Poisson distribution. But before we move further into what we have for today, let us do a quick review of our previous lesson. Okay, welcome back. Now when you talk about Poisson distribution, I stated that it's a form of probability distribution but in a discrete format. It's a discrete form of probability distribution. Now, Poisson distribution is most suitable when the number of trials is very large. You know, when the number of trials is low, we make use of the binomial distribution. That's if the number of trials is very low. But if it's high, we make use of the Poisson distribution. And the probability of success is small. It is defined as the probability of, now we have lambda raised to the power x, where lambda is NP. And most times lambda serves as the mean of the distribution. So lambda raised to the power x times exponential of minus the mean, where the value of s ranges from 0 to infinity. So this is the basic law that explains the Poisson distribution, and it is used during analysis of a probability distribution. So I would really like us to do some calculations to understand how Poisson distributions work. Now, if you look in front of you, you'll see if 8% of a particle is in a large consignment are defective, what is the chance of 30 articles? You can see it is very large. The number of trials is large, 30 articles selected at random will contain fewer than 3 defective articles. Now with this, we're talking about the Poisson distribution. Now let's bring out our probability first. The probability of interest is, they say 8%. So the value of our P is equal to 8 over 100, which is 0.08. That's the value of our P. Then the number of total number of trial is 30 in number. So with this, let us apply the Poisson distribution. Before we do that, we have the value of lambda as NP. It was stated. So you now have 0.08 times 30. So the value of our lambda becomes 2.4. That's for lambda. Now, for the probability, fewer than 3, it means probability less than 3. So we are talking of the probability of 1 plus probability of 2 plus probability of 0. So we are talking from 1 to 3, then we add the different probabilities. So let's do that. Of probability of 0, we have PR of 0 is equal to, don't forget the Poisson distribution, the equation for the Poisson distribution, we stated it as lambda raised to the power x e raised to the power minus lambda all over x factorial. So we start by for p raised to the power 0, we now have our lambda is 2.4 raised to the power, our x is 0, then at the same time we have it times exponential, the value of our e, we just leave it as e minus 2.4 all over, because the value of this is 2.4, all over 0 factorial. Now with this, our value here is 1 times e raised to the power minus 2.4, which is equal to e raised to the power minus 2.4. Now for PR, where probability of 1, applying this rule into it, we have the value of lambda, which is constant, but this time is raised to the power 1, exponential minus 2.4 all over 1 factorial. So we now have 2.4 times e raised to power minus 2.4 over 1. And this is the value for here, 2.4 times e raised to power minus 2.4. Now for PR2 is equal to 2.4 raised to power 2 exponential minus 2.4 all over 2 factorial, which is equal to 2.4 raised to power 2 exponential minus 2.4 over 2 times 1. And your value here will be 2.88. Our value will be 2.88 times e raised to power minus 2.4. So with this, the probability of x being less than 3 is equal to probability of x equals 1 plus probability of x equals 0 and plus probability of x equals 2. So which is equal to e raised to power minus 2.4 plus 2.4 times e raised to power minus 2.4 plus 2.88 times e raised to power minus 2.4. So our final answer now becomes 6.28 times e raised to power minus 2.4. So the probability of selecting a random, selecting a number that will contain less than 3 defective is equal to 6.28 times e raised exponential of e raised to power minus 2.4. Okay, thank you for being part of today's lesson. I would advise you to take the test that will be coming up shortly on your screen. So thank you. See you in our next lesson.